This is hitting screen. Your video is off, your mute is on. Your mute is off.
Good afternoon, gentlemen. Can everybody hear me and see my screen? Is there anybody there? Awesome. Okay, well, I'm just going to give it a few more minutes to let a few more people join, and then we'll kick off. Righto then, gentlemen. I think we're going to get started. There may be a couple of people joining later on, but let's just kick off, shall we? So what I'm going to do today is I'm going to start by giving you a little bit of a run through of who we are. I appreciate some of you on the call today might not have dealt with Cadpro in the past. So I just want to spend a few minutes kind of introducing myself and who we are and what we do. Just bear with me a minute. You can get PowerMill to work no problem, but Zoom is a little bit more challenging. Just bear with me. There we go. Okay, so just a little bit about myself. My name's Daniel Malloy. I'm a manufacturing technical specialist here at Cadpro Systems, and I look after PowerMill and FeatureCam. So Cadpro has been around for about 25 plus years now. We're 100% New Zealand owned and operated. We also have offices in Auckland, Christchurch, and Sydney. So we've got a fairly wide base. We can cover both New Zealand and Australia completely. There's a few different market segments that we're involved in. So obviously today we're focusing on PowerMill, which is going to be the production, design, and manufacturing side of the business. But we also deal with architecture, engineering, civil. So we really have a wide range of industries that we're involved in. There are currently 28, 29, if memory serves, of us. Between us, we've got around 150 years of experience across a wide variety of industries. So we have a strong emphasis on technical skills and abilities. So we're able to efficiently support all of the products that we sell. So this is the current suite of Autodesk manufacturing products. So there really is a wide variety of solutions that we can provide. Obviously, for today, we're going to be focusing on Autodesk PowerMill. This is just a very quick video, largely because I just think it's really cool, which is actually a joint project between Malloy and Autodesk to produce this demo part. So really beautiful machine, really beautiful part. Just give you an idea of the type of thing that can be done with PowerMill. So why PowerMill? Why PowerMill over everything else? Dedicated, expert, and trusted. It is a dedicated CAM system. It is not a CAD system built into it. It is specifically designed to do CAM. It has been around for more than 20 years, and it is industry recognized as one of the industry recognized a solution to produce fantastic quality parts. So what can we do with PowerMill? The first thing, high-speed roughing operations. So I'm going to show you through this a little bit later on. But one of the most interesting aspects of this is called vortex roughing. Now this aims to basically keep a constant load on the tool, allowing us to increase tool life while reducing cycle times. Really, really interesting piece of kit. As I said, I'm going to give you a bit of a demonstration of that later on. Can also do 2D milling, which covers feature detection again, which I will demonstrate later on, drilling, pocketing, and chamfering. So we really have a wide range of 2D milling operations. On top of that, we have 3+2 machining. Very, very useful for reducing tool push off, just a full utilization of a full 5-axis machine. We also have full 5-axis simultaneous commands, including swirl finishing. We also have tool axis control, which is a really, really interesting part of the system. It actually allows us to dynamically change the orientation of the tool to prevent any clashes, etc., etc. Mill turn, we're going to leave that one for today. We do have the ability to do mill turn within PowerMill, but as I said, for today, we're going to focus just on the milling. And also robotics. So we have the ability to program a wide variety of robots, a really, really interesting part of the system. Again, for today, we're just going to focus on milling, but if you'd like any more information on that, I'd be more than happy to walk you through it. So what impact does PowerMill have? Improved quality. This is, I'd say, the main focus of PowerMill is producing high quality parts to really tight tolerances. We do this in a number of ways by having a large number of finishing strategies, which allows us to not have the need to do manual polishing after the fact. Also allows us to meet delivery schedules by allowing efficient programming of parts and improve throughput, maximizing capacity. Expert levels of control and optimization. Okay, so we touched on this a little bit before. Increased precision, as I said, we'll give you a good demonstration of what that means later on. Excellent surface finish again. Greater efficiency really is really about creating an incredibly efficient program very quickly. So again, we come back to impact. Greater control and flexibility to reduce the cycle times, repeatability and standardization. So this is something that allows us to automate repetitive tasks. So an example of this would be our tool library. So instead of creating tools on every occasion, we can simply create a library and import them as necessary. Maximize return on investment of CNC machinery. Again, this really comes back to getting the very most out of the machinery that you have by using an efficient CAM system. Trusted to deliver. Now, as I said, PowerMill has been around for more than 20 years. It is an industry-proven piece of software. So how do we produce these efficient results? Well, one is by stock simulation. So what this allows us to do is to produce accurate representations of machine stock at any point in the machining process, simulate the effects of feed, speed, tool geometry, and the number of teeth on your machine parts, identify hazardous machine motion that could degrade surface finish, and highlight regions of stock where additional machining needs to take place. Okay, so I'll give you a bit of a demonstration of that last one a little bit later on, where we can actually take a model that we've already machined and actually run assessment on it to see if there are any gouges on the model or potentially if there's any material left over. Collision check and avoidance. So this allows us to check tool paths for collisions and near misses between the cutting tool, fixture, workpiece, and CNC machine. So this is essentially clash detection. If the system's going to detect a crash, it's going to tell us that there's an issue there and that we need to correct it. Use 5-axis tool tilting to avoid collisions entirely with smooth motion for maximum surface finish. Now, this isn't something that I'm going to have the time to cover today because it is sort of a topic in itself. But if you would like more information on that, I would be more than happy to run through that with you. So what are the benefits of using PowerMill? Well, increased confidence. So we touched on that in the last slide. The PowerMill verification tool to confirm toolpath and NC program are safe to use. Major problems can be identified and fixed early in the programming process, ensuring that programs are ready for use on your 3 or 5-axis machines. In many cases, programs are of such high quality that they can just be run on the machine unattended. Okay, so this basically involves you can start the machine when you go home at night, run it overnight, and when you come back, the part's finished in the morning. So what does this lead us to? Well, better use of our workforce. Machine operators are not stood watching the machine. While one part is being machined, they can be programming the next one. The workforce can also supervise multiple machines or redeploy to focus on other tasks. Leaving the CNC machine doing what it does best, producing great parts. Feeding a machine with high quality NC programs ensures that you always produce the best quality parts. Protecting hardware investment. Now, I'm sure this is the one that everyone is pretty keen to talk about. Obviously, modern CNC machines, incredibly complex and expensive pieces of equipment. A single machine collision can run into thousands of dollars worth of downtime and repair bills. So it's really important that every program that we send out to the machine, we know is going to produce exactly that part without problems. Reduce machine downtime. Again, this is really linked to the last statement. By ensuring that every code that we put out is exactly as we want it to be, we're going to reduce machine downtime by reducing incidents. And that comes to the end of the presentation. So I think that's probably enough talking. for the time being. What I'd really like to do now is get stuck in and actually show you a little bit of PowerMill. So let me just minimize this. Okay, so you should be able to see my screen now, you should be able to see PowerMill. So what I'm going to do is I'm going to take you through how I would program this simple part. Okay, it's going to show off a lot of what I've just talked about, and it will give you a good idea of the workflow of PowerMill. So how we go about creating op stock, how we go about creating tools, toolpaths, verification, and then finally at the end I'll actually show you how we produce NC code. Okay, so what I'm going to do to start with, just give you a very quick overview of where everything is in the system. Okay, so obviously in the center we have our part window, which we can manipulate around. So we can hold our middle mouse button and drag anything around that we want. Over on the right hand side, we also have a number of shortcuts. This is usually used to manipulate the view and what we see on the screen. Over on the left hand side, we have our Explorer. Now this is going to be where all of our NC code, all of our toolpaths and all of our tools that we've created are going to be listed. Obviously, we haven't got a lot in here at the moment because we haven't started. And up at the top is our taskbar. So this is where we access all the different features of PowerMill. If I can get that to go away again. Okay, so what I'm going to do to start with, the first step whenever we open up a new part in PowerMill is always to produce our stock. So I'm going to come up here and select block. Now this allows me to do a number of different things. So first of all, I could physically go in here and input the figures that I want for my stock. Not a problem at all. But what I can actually do is I can hit calculate. And what it's then going to do is it's going to shrink that stock down to be the same size as our part. So at the moment, this is shrink wrapped exactly the size. So what I'm going to do is I'm actually going to come in here and I'm going to say add 2 millimeters on in the Z, just so that we've got something we can come in and face off. When I'm happy with that, close it down. The next thing I'm going to do is I'm going to come into my Toolpath Connections tab. Now this allows me to set up my clearance planes. So again, with PowerMill, the process is always the same. We create the stock, then we set up our safety planes before we do anything else. So at the moment, by default, the system gives us a rapid clearance of 10 millimeters and a plunge clearance of 5. Now you can come in here and change this if you want, but for the moment, I'm just going to say hit calculate. I can then also turn on a visual representation, so I can actually see where those planes are going to be above the parts and make sure they're in the correct place. Once I'm happy with that, turn both of those off and close this down. Okay, so what's next? Well, before I can produce any toolpaths, I'm going to have to create a tool. Now, there are a number of different ways of doing this. I can, if needs be, just come into here and create a tool from scratch, so literally input the dimensions as we go. But what we encourage people to do within PowerMill instead is to use our tool database. So I'm just going to click into here, let this load. Oh, and it's loaded on the other screen. Let me just drag this across. So this is PowerMill's tool database. Okay, now by default, I'm using just a generic tool group. Okay, so this is just something that ships with every version of PowerMill, and it's just a set of standard tools. But what you can do, and what I would certainly encourage, is for you to actually create your own tool libraries based on what you have in each machine. So what we can actually do is we're not limited to just one tool library. We can have a different tool library for each machine that we have in the shop, and it's really easy just to switch between them, so we always know what tools we have available to us. So down here, we can see all of the different tools that are in this database currently. And up at the top here, we can see the section for type. So I can actually filter the database by the different types of tool. So what I'm going to do is I'm going to select tip radius tools, hit search, and then the system displays all of the different tip radius tools that we currently have in our library. So I'm going to select the biggest tool to start with, a 50 mil, just to try and get rid of as much material as we can. Hit create tools. And now I'm going to close that down. And we can see that tool's been created there. So the next thing I'm going to do, now I've got a tool, is I'm going to need to create a new toolpath. So again, up here on my taskbar, I'm going to select toolpaths. It's always going to put it on the other screen. and that displays our strategy selector. So we see a similar form here to what we see with our Explorer over on the left-hand side. We have a number of different groups of strategies. Okay, so we have, for example, 3D area clearance, and we can curve machining, feature machining, or we can click through these and it shows all of the different strategies that we can employ. We do also have a search bar if needs be. As I mentioned earlier on, PowerMill has a huge array of different strategies that we can employ. So it's a really slick way of putting things into categories and makes it easier for us to find our way around. So what I'm going to do to start with, I'm going to select curve machining, and I'm going to pick this face milling operation. Press OK. Always on the other screen. And now we get our toolpath window come up. So again, similar form to what we've already seen. Over on the left-hand side, we have an Explorer with different options that we can go through. And over on the right-hand side, we see whatever option we have selected in the Explorer, all the different options displayed there. So if I click through, you can see all the different options are displaying. Also up at the top here, we have the option to give this a toolpath name, which I thoroughly recommend and honestly very frequently forget to do. With simple parts, it's not so important, but when you get to very large, complex components, it makes life much easier if you've gone through and named everything. If you have the toolpaths named 1, 2, 3, 4, 5, 6, if you ever want to come back to it, it does become really difficult. So I'm going to name this top face. Now we have the option here to pick where our face is going to be located. Now we've currently got it at 0, which is actually where our coordinate system is, as it's located on the top of the model, so that's okay. And I'm just going to come in here and change my step over to say 20 mil and press calculate. Close this down. So there we go. We have our first operation. So now that we've got our first op, what we want to do is simulate that. So under here on the toolpath, we can see the operation that we've just created. If I right click on there, press simulate from start, and the system then takes us into our simulation workspace. First thing I'm going to do is I'm going to turn on my view mill, which will allow us to see the stock that we've created. Now I'm going to just slow this down a little bit so we can see it. Press play, and there's our first operation. So once I'm happy with that, I'm going to come up here to the taskbar. I'm going to press store. So what this allows us to do is literally save the simulation in its current state, so that when we produce additional operations, we don't have to watch through the ones that we've created every time. We can simply just come back to this point. I'm now going to say mode and select no image. So that's basically just going to hide away our stock so that we can see more clearly what it is we're trying to, the next operation that we're trying to produce. So I'm just going to hide this toolpath away. It's not a necessary step. You can leave everything on the screen just for the sake of this. It just makes life a little bit easier for us to see what we're doing. So now it's time, next operation. So I'm going to come back to my home tab, select new toolpath. Again, I'm going to come into my now 3D area clearance, and I'm going to select model area clearance. This is our standard kind of roughing operation, if you will. Press OK on that. Again, first thing I was doing here, come in here and give this a name. So we'll call it outside rough. We've got a number of different styles of roughing that we can do in here. So for the moment, I'm going to select offset model. Vortex I discussed very briefly earlier on, which is a high-speed milling operation, which I'll show you in a second. For the moment, though, I'm just going to select offset model. I'm also going to leave a thickness on. Now, what this does, this is essentially stock to leave. So what I'm going to do is I'm going to leave 1 millimeter of stock on the walls, and I'm just going to finish the floors to depth. I'm being just a little bit crude just for the sake of speed in this one. I'll step over, I'm going to leave it 20 mil, and I'll step down, I'm going to change that to 10. Now before I do this, I'm just going to come in here to my limits tab. I'm just going to change a couple of things in here. So the first thing I want to show you in here is this block command. So by default, the tool is currently set so the center of the tool will never pass outside of the stock. But to get around this edge here, we're going to need it to drive around the outside. So I'm going to switch that. I'm also going to set some Z limits here. So what I can do is I can actually specify between 2 points in Z where I want to machine between. I can input the figures if needs be, but a much slicker way of doing it is to actually select this icon here. And now I can actually pick that directly off the model. Do the same with my lower limit and press calculate. Okay, so there we have our first roughing operation. So I'm just going to simulate that. So right click on the operation, simulate from start, turn my stock back on. I'll just speed this up a little bit and press play. Okay. So that looks pretty good. One thing I do notice though is that we are leaving some fairly big scallops on these walls here. So before I come in and finish this, I'm really going to need to clean these up. So there's a number of different ways I could do this. I could produce another operation, essentially a semi-finishing op, in order to come in here and remove some of this material. But what I can actually do within PowerMill is actually build that logic into my roughing operation. So what I'm going to do, I'm going to hit restore. That's going to take my simulation back to the state it was before we ran this operation. And now I'm going to come in back into this operation, press settings. Notice I don't have to leave my simulation workspace for this. I can edit everything on the fly. Going to let that load. And now under step cutting, I'm going to enable this. And what this is going to do is it's going to actually assess the model, and if needs be, it will then add additional passes in at the figure that we've specified, currently 2.5 mil, which is just going to help us to reduce those scallops. So essentially, we're going to be doing a roughing and a semi-finishing operation all in one here. Press calculate. Close that down. In fact, let me just hide this away just so you can see those on. So you can see the cuts that we've added in here. Again, if we now just simulate that. So particularly if you have, extremely complex models with lots of angled faces, this can be a huge time saver for the programmer. Okay, so I'm pretty happy with that. So I'm going to hit store there. Minimize this again. And I'm actually going to hide everything away now just so we can see our model again, just to make life easier for ourselves. So the next thing I'm going to do is produce an operation to rough out this top pocket up here. So the first thing I'm going to have to do is create a new tool, because at the moment our 50mm tool isn't going to fit through this slot here. So again, I come back to my home tab, go back into my tool database, and now I'm going to select, say, a 16mm tool. Hit create, we'll import that into PowerMill. Okay, so we're ready to go. So the next thing I want to show you with this is our feature recognition. So if I come up here in the feature group, I can actually say detect. So instead of actually just defining boundaries, picking off the model, what it is that we want to machine, we can actually let the system do a lot of that work for us. So now I'm in feature recognition mode. If I hover my cursor over the part, we can actually see all of the different features that PowerMill is finding. So what I'm going to do is I'm going to select that top pocket, hit accept, and we've now defined that pocket as a feature. Come back to my home tab, create another new toolpath. This time I'm going to select my feature machining operation, feature area clearance. So this is really similar to the operation that we've just produced. It's just that it's designed to work with whatever features we've created instead of assessing the model. Press OK. Okay. So again, as you may well realize, very similar form to what we saw before. But now what I want to show you is our vortex roughing. So this is PowerMill's high-speed roughing operation. The aim of this is to maintain a constant load on the tool. So the advantages of this are reduced cycle times, and because we're always maintaining a constant load on the tool, we usually see dramatically increased tool life as well. So a really, really useful tool. So I just want to give you a quick demonstration of that. So I'm going to leave most of these things the same. I'm going to leave my 1mm on the wall. Again, we'll come back and clean that up later on. But this time, 20mm step over with a 16mm tool is a little bit extreme. So we're going to put that to 8, so a 50% step over. Give this a name, call it top pocket. Hit calculate. And there we have our high-speed roughing operation. So again, a very different form to what we saw before. Just want to show you what that looks like. Simulate that from start. Just slow this down a bit so we can actually see what it's doing. Okay, so a really, really efficient roughing strategy. Once I'm happy with that, store it again. Minimize my stock. Help if I press the right button. There we go. Okay, so now I want to look just very briefly at some of the 5-axis simultaneous operations that we can produce within PowerMill. As I said at the start, PowerMill is really good at producing very high quality, very complex parts. So its strength really lies in its sort of 3D and its 5-axis operations and the ease of which they are created. So I just want to show you through that very quickly. So I come back to my Home tab again, another new toolpath. This time I'm going to select Finishing. So you see, just to give you a quick idea, the number of different finishing strategies in PowerMill is immense. There are a huge number of options, and all of it is aimed at giving you as much control over the toolpath as possible. So what I'm going to do, I'm going to come down to the bottom. I'm going to select Swarf Finishing. Press OK. Okay, again, first thing I'm going to do, give this a name. And I'm actually going to do very little in here before I start. All I'm going to do is I'm going to increase my tolerance. So what this will do is this allows the tool to essentially follow the surface more accurately. It will never deviate more than 0.01 mil away from the surface. So for roughing, I usually use a tolerance of 0.1. For finishing, 0.01 or even down to a micron in some cases. But all I need to do to produce this operation is actually pick the surfaces that I want to machine off the model, press calculate, and there we have our swarf milling operation. So I'm just going to run that through very quickly. So again, we'll simulate that from start. I'm just going to slow this right down so that we can see what it's doing. Okay, so I can see a bit of an issue that we've got straight away. They're actually plunging the tool through material on the edge here, so we need to adjust that. Just speed this up a little bit, or we'll be here all day. Okay, so we need to do a little bit of work on our lead in, lead out. So that's obviously not an ideal situation. Also, if I bring on a side view, you can actually see that we're going to potentially leave a little bit of material at this bottom edge here. Because by default, what the system will do is it will drive the very bottom edge of this tool here down to the bottom edge of here. So there's potential for us to leave a little cusp there. So what we could really do is be able to offset that toolpath slightly just to make sure we don't leave any marks there. So again, I'm going to hit restore. Come back to my isometric view just to allow us to see what we're doing a little bit more easily. So now I can come back into this operation and make a couple of changes here. So I'm a big advocate for just get something on the screen. PowerMill is very, very quick at recalculating toolpaths. So, don't be afraid to just get something on the screen, have a look at it, and then come back and make any changes if necessary. So the first thing I'm going to do, I'm going to unlock this toolpath. I'm going to come down here to my position tab. And this allows us to actually offset the toolpath. So what I'm going to do is I'm going to put in a figure here of say -5. If I switch to a side view again, just so we can see what's happening. If I now press calculate, that toolpath will now have actually been offset down this face by 5mm. So that will eliminate us potentially leaving a mark at this bottom corner. Next thing I'm going to do is I'm going to come here to my leads and links. I'm going to select lead in to start with. So the first choice, I'm going to select surface normal arc. We'll have a linear move of, say, we've got a 60mm tool, so we'll make the linear move, say, 8mm, a 90-degree angle, and a radius of 8. Lead out. Again, we could come in here and input what we've just inputted for the lead in. Or what we can actually do instead is just copy our lead in to our lead out. Then we just switch back to isometric view, press calculate, close that down. So we can see that lead and link has that lead in and lead out has been added. So again, if we just simulate that, much better. Okay, so hopefully that's giving you a bit of an idea of just how easy it is to produce these kind of toolpaths within PowerMill. As I said, this is really a big strength of the system. So once I'm happy with that, again, store that away, minimize everything. Let's get rid of this toolpath, get rid of this tool so we can see what we're doing. And the next thing I'm going to do is produce a 3D operation to produce this top fillet around here. Okay, so what I'm going to do this time is I'm going to need to create a new tool again. So again, come back to my home tab, tool database. This time, instead of using a tip radius tool, I'm going to want to select a ball mill. So we're going to search our library for that. Select our 6mm ball nose, create that tool, close it down again. So now what I'm going to do is I'm going to create a boundary. Now what this is going to do is it's going to limit the toolpath to just machining these surfaces here. So I'm going to come up to my boundary tab, say create a boundary by the selected surfaces, pick the two surfaces, press apply, and there's our boundary created. Press accept to close that down, and now we're ready to produce this operation. So come back to my home tab again, another new toolpath. This time again, sticking with our finishing operations, I'm going to select optimized constant Z finishing. Just let that load. Again, come in here, give this toolpath a name, so we'll just call this one fillet. Okay, so what am I going to need to do here? Well, firstly, what I'm going to do is I'm going to need to change this step over. 8mm step over, 6mm tool. Again, that's not going to be so good for us. So I'm actually going to set this to say 0.5 mil. And I'm also going to turn on spiral. So what that's going to do is it's going to produce this fillet without retracting the tool. It's just going to keep spiraling down. So again, this is very good for minimizing any witness marks that we might leave on the part as the tool comes on and off. Hit calculate. And there's our filling operation. So again, really, really easy to produce. Just run that through on the simulation. Make sure we're happy with everything. Okay. And if I just hide that toolpath away so we can get a better idea of what it is that we've actually produced. Okay, that's looking pretty good. Again, once we're happy with that, store it, put it away, and now we're ready for the next operation. So the next thing I want to show you through is just a little bit of drilling. So we've got these two holes here. If we actually look down at them, so we've got a flat bottom in them. I don't know the diameter at the moment, so what I'm going to do is I'm going to come up to my home tab, and I'm going to select measure. What this allows me to do is actually dynamically interrogate the model and extract information from it. So I'm going to select diameter. Now anything I hover over, it's actually going to show me what the diameter is. Okay, so it's an 18mm hole. Close that down. So I'm going to need to produce some more tools here. Again, we'll come back to our tool database. And this time I'm going to look and pick a drill. Search the database. Okay, so what have we got? We've got an 18mm chamfer drill, and we've got a 12mm as well. So what I'm going to do is I'm actually going to pick both of those, so we can actually extract multiple tools from the database in one go. So with both of those selected, I'm going to hit Create Tools. You may notice on the left-hand side that both of those have been created. And the last thing I'm going to do is I'm going to need to pick an end mill as well, just to come in here and produce this flat bottom. So so this time I'm going to pick end mill, search, and we'll pick, say, let's go with a 10mm end mill. Okay, so before we get started on this, what I'm going to do is I'm going to define these as a feature. So a similar trick to what we pulled with this top pocket. I'm actually going to define these as a feature. This just makes our life a lot easier. We don't have to mess around with defining depths because the system can pull all that information directly from the model. So under whole feature set, can actually pick. So I've selected both of those holes. Can now press create. I can give these a name. As this is going to be the only one we're going to produce, I'm not going to bother in this instance. Hit apply. We can now see those have turned yellow, meaning that they're now defined as a feature. So now I'm ready to go. Back to my home tab again, new toolpath. This time I'm going to select drilling. I'm just going to select the standard drilling operation to start with. So what I'm going to do here is I'm going to produce 3 operations. So the first is going to use my 18mm drill, and that's actually just going to be used to spot these holes. Then I'm going to drill them to depth using the 12mm, and then I'm going to come in with a helical operation and produce that flat bottom with our end mill. So again, first thing we do, give this a name, so we'll just call it spot. Under the operation type, currently we're set, and by default it's drill the hole to depth. What I'm actually going to do instead, I'm going to select chamfer, hit calculate. That's all I need to do. As I said, the system has pulled all of the dimensions from this hole directly off the model, so we don't need to define any depth. We don't need to do any of that. It figures it all out in the background for us. So we can see it's actually produced our spotting operation. What I'm going to do is I'm actually, just for the sake of speed, going to produce all these operations, and then we'll simulate them at the end. So the next operation I'm going to produce is actually pretty similar to the one that we already have. So instead of closing this down, creating a new toolpath, going through all that rigmarole, what I'm going to do is I'm actually going to select this button at the top here, which basically gives me a copy of the toolpath that I've already created. So you may notice in our Explorer, so we now have spot, which is the operation we just created, and spot_1, which is an exact copy of our original toolpath. So what I can do now, just come in here, change the name to drill, change our tool as well, because we're currently on the 18mm drill, change that to 12, change my operation style to drill hole to depth, calculate that, and we can now see that drives the 12mm drill right to the bottom of that hole. Lastly, again, to produce our helical operation, we can pull exactly the same trick again. So I say, give me another copy. This time I'm going to call it helical, change the tool again, this time pick our end mill. And then under our cycle type, I'm now going to select helical. So as you can see, it's really, really easy to produce a lot of similar operations in a very short space of time. We're not having to start from scratch. We can use a lot of what we've already produced. So I'm just going to hit calculate on that. Again, let's just see what we get, and then we can make any adjustments if necessary. That's probably the pitch on that's probably a little bit extreme. So I'm just going to come in here and modify that. We'll put that on, say, 52mm pitch, maybe not. Make that 5mm. And there we go. So now I'm happy with all those. Close this down. And we can simulate all of these operations. So let me just show the right tool. You can play that. So there's our spot drilling operation. Next, we're going to drill the holes to depth. And then finally, our helical operation just to come in here and clean up that material at the bottom. Okay, so that completes our drilling. So I've got a couple of things left to do on this model right now. So we've still got to clean up the 1 millimeter that we left on the walls here. And we also have to produce this, this pocket on the side here. So what I'm actually going to do is I'm just going to hit remaining material. What this is going to do is it's actually going to go off and assess the model and see where there's any material left. So purple, it indicates there's a large amount of material left, which is what we'd expect. So we can actually get a visual representation of where there's material left and where the part is completed. Close that down. Store that away. Minimize everything, and let's just get everything off the screen so that we can see what we're doing. Okay, so next I'm going to produce an operation to come in here and clean up this 1 millimeter on the walls here. So there's a number of different ways that we could do this. We could produce an operation for each instance. So what I mean by that is we could produce an operation to come in here and clean up this bottom surface, then another operation to come in here and do the top. No problem with doing that. It certainly would work. But what we can actually do is use PowerMill's built-in intelligence to do a lot of the work for us. So what I'm going to do, come back to my home tab again. I'm going to pick up another new tool. I'm going to pick, say, a 16 mil end mill, just so we can really plow through this material. We'll create that tool. Close that one down. And now I'm going to create another new tool path. So again, I'm going to go back to our finishing now. I'm going to select corner pencil finishing. Now what this does is this will actually assess the model, find where there's material left, and produce the operation to remove that material. Okay, so we'll give this one a name again, call it corner cleanup. And as I said, this is a really automated operation, so there really is very little that we need to do in here. So if I just hit calculate, and we get significantly less toolpath than I was expecting. Okay. I suspect we have possibly a limit set over from a previous operation. I just come into my limit tab here. Let me just check. So we have our boundary selected that we had to produce this top fillet here. It's been lingering around. So I switch that back to none. Hit calculate again. And there we go. Okay, so I can see we've produced the operation to clean up that bottom surface and at the top. I can also see a few issues that we're having here though. First of all, we're not driving the tool outside of the block, so that's going to be an issue that we need to correct. So let's do that first of all. So again, under our limit tab, I'm going to switch it to be able to go outside of the block. Press calculate. There we go, that's corrected that issue. The other issue I can see as well is that the system, quite correctly of course, has picked up that there's material left in these pockets here, which we haven't produced yet, which is of course true, but it's really not what we want to be doing with this operation. Now, one of the, for me, the most impressive things about PowerMill is the ability to be able to actually manipulate toolpaths after you've created them. So what do I mean by that? Well, this toolpath, we just don't want it. We want these sections here. Ooh, if I can pick them. Oh, it's not playing ball. We want the ones at the bottom, out of the top, but this we just want to get rid of. So what I'm actually going to do is I'm actually going to just select them. So I can select all parts of the toolpath that I do not want. I can now come up to my toolpath edit tab, and I can just get rid of them. The system in the background then retrims all of the moves for us. Do the same on the other side. Pick what I don't want, delete it, and that operation is now correct. So really, really powerful tool. So you know, if ever there's a situation where the toolbar is just not exactly what you wanted, you have an awful lot of control in PowerMill to then be able to manipulate that without having to recalculate everything. So again, let's just run that through on the simulation. Speed that up a little bit, or we'll be here all day. Oh, there we go. So the last thing we've got left to do now is just to produce 3+2 operation in order to come in here and mill out these pockets. So again, store that, put everything away, get everything off the screen, clean everything up. Okay, so how do I go about doing this? Well, the first thing I need to do is to create some coordinate systems in order to tilt the tool over to be able to get into these pockets. Now, PowerMill has a really slick way of doing this. So again, if I come up to my feature group, so the same trick that we pulled on this top pocket, I'm going to use my feature recognition. But this time, instead of selecting single feature, I'm going to select similar. All this will do is this actually allows the system to pick other instances of similar features on the model. So if we, for example, if I hover over the drill holes, it picks up both of them. But we can do the same thing on these side pockets here as they're similar to each other. Press accept. So I've now defined those as features. I come down here in my feature group, can actually see the number 2 and 3. They're both there. So what I'm going to do, now all I need to do to create my coordinate system is just come up to my taskbar here, select activate workplane. And we've run into a little bit of an issue. Something I forgot to do at the start. So by default, the block is always linked in PowerMill to the active workplane. So when we've moved the active workplane, it's also moved our block, not what we wanted. So all I need to do to correct that is just pick an operation so it moves back to where it was. Come back to my home tab, come into our block. And now under our coordinate system where we had it set at active workplane, I'm now going to set that to global transform. Okay, so if you make mistakes like this right at the beginning, it's not an issue. You can come back and modify them later in the build. It's not a case of once they're set, they're set. You're free to manipulate them whatever time, whenever you like. Press accept. And now when I activate that, the block should stay where it is. There we go. Let's close all this down. So I can pull the same trick on the other side. Feature group, activate workplane, and we can see it's then created our coordinate system in the correct orientation for that part, for that pocket, sorry. All right, so I'm ready to produce these operations now. So again, I come back to my home tab, come into my database, and now I'm going to need to select another tool to fit into these corners here. And I'm not sure exactly what the radius is of these corners here. So again, I'm going to come back to my measure command, select diameter. Again, if I just hover over this, 6.42. Nice to give us a nice round number. So I'll just press escape there. So under our end mill, I'll pick, say, a 6mm end mill. Create that tool. Close that down. And once again, create a new toolpath. Come into feature machining, feature area clearance. The same trick as we pulled before. Come in here, give this a name, call it, say, pocket 1. And what I'm going to do now, I appreciate we're running a little bit short of time, and I do want to leave some time for questions and answers at the end. So I'm going to be a little bit crude with this. I'm just going to say finish it in one operation. Come in here, change my step over to, say, 3mm. I'm going to set my limits to, say, just move this over. So we want to limit the toolpath so it's only being produced below where our coordinate system is. So I'm going to set that to, say, 0. Calculate. And the system comes up with an error message at this point. Or not an error message as such, but a warning. So what it's actually done is it's assessed the toolpath that we've created, and it said, hey, at some point during this toolpath, you're going to be plunging the tool directly into the material. So that's telling us, okay, we've got a bit of a problem there. So I'm going to press OK. And I'm going to come down to my leads and links. And this time, for my lead in, I'm going to select ramp, calculate that again. And now we can actually see we're going to be ramping into this pocket, and that error message has now gone away. So the system, as I said, does a lot of thinking for us in the background. And if it looks at something we're doing and says, hey, this could potentially be dangerous, it's going to flag up a warning for us. Okay, so pretty happy with that. So the next thing I want to do is to produce essentially the same operation, but on the other side of this part. So again, we're going to pull the same trick as we pulled with our drilling. I'm going to say, give me a copy of this toolpath. Name this one, say pocket 2. And now under features, I'm just going to switch to the opposite side, switch my work plane as well, calculate that, and there we go. So we'll just run those 2 last operations through. Let me bring up an isometric view so we can see what we're doing. So there we go, and the very last one. Okay, so that completes our component. The last thing I want to do is actually to produce an NC program so we can actually send this out to the machine. So what I'm going to do, under my Explorer, NC programs, I'm going to select create new program. Again, give this a name. I'm just going to call it, say, 1001. It then asks us for a machine option file, which is essentially a post processor. So this is what actually takes all the pretty pictures that we see within PowerMill and gives us some G code that we can send out to the machine. So I'm going to pick, say, I've got a HAS UMC 500 post here, accept that, close that down. And now I just need to add all these operations. So I'm going to select them all, right click, add to NC program, and then we can say write. And the system goes off and it writes all that code in the background for us. Last thing to do, just want to view that code. So I come over to my NC program tab, I can say open. It's going to open our code in the external editor. So that completes the demonstration for today, guys. I appreciate that was quite a kind of high level overview. We didn't have an awful lot of time. So what I would encourage people to do is, if you have any questions, you feel free to ask them now if you wish. You can also get hold of me after the fact if you have any other questions or require any more information. I'd be more than happy to help. I also don't know if any of you can speak. Are you all muted or can you talk? No, I think you're all going to be muted, aren't you? And as I said, I do know how to work PowerMill, but I do not know how to work Zoom very well. So following this meeting, you should be getting a follow-up email from my colleague, Jonathan, who will actually give you all of my contact information. So if you wish to reach out, feel free, more than welcome. As I said, if you do have any other questions, feel free to stick them in the chat box. We've got a few minutes left, so I'm more than happy to go through things with you if needs be. If not, if everyone's happy, then we can call it quits there. Other question is anybody still awake? Very good question. Okay, so Fusion 360 proves to be good for the vast majority of situations, but PowerMill gives you a lot more control over it. So the way I think of it is that Fusion 360 is a slightly more basic version. Okay, so you do get less control, you get less options for finishing strategies. You also get less option for toolpath control as well. So for particularly large models or poor data, where surface finish is incredibly important, that is where PowerMill comes into play. So the answer is really very large models and where surface finish is hugely important. That is where PowerMill comes into play. And I wish I could figure out how to unmute you, but I can't do it. No problem at all. There you go then. Doesn't matter, I can't unmute you. Righto then, gentlemen. Well, if there are no further questions, then I will leave it there. But as I said, I do encourage you, if you know, after the fact, if you come up with any questions or want any more information, please feel free to get in contact with me. I'll be more than happy to answer any of your questions. Okay, gentlemen, I will end the meeting there. Thank you very much for your time.